So today we are going to learn about the formulas for the derivatives of many important functions. We can write down immediately the corresponding formulas, which is referred as a standard formula for the integration of these functions. So here we can see that derivative of d by dx, derivative is always represented as d by dx. Now d by dx is a derivative formula where it is x power n plus 1 divided by n plus 1 equals to x power n. So what is the formula for x power n in the integration? It is a anti, like it is a corresponding of each other. It is antiderivative of each other. Integration is called as antiderivative and they are opposite of each other. You can see here d by dx of x power n plus 1 divided by n plus 1 is the formula for xn. So that same formula, integration of xn will change it to x power n plus 1 divided by n plus 1, and this plus c we have to write it for integration, indefinite integrals. We have to write the constant c for every problem. So here we can see that the question of different derivatives is changing as answer in antiderivative. So they are opposite of each other. And you can see here differentiation of d by dx of x, derivative of x is 1 and derivative integration of 1 is x plus c. So we can easily understand that derivative and integration are opposite of each other. Then we have the second formula is derivative of sin x is equals to cos x and integration of cos x becomes sin x. You can see there the question of derivative is changing to cos x, and then cos x integration is changed to sin x. Then minus cos x is equals to sin x and integration of sin x is equals to minus cos x. Then tan x is equals to secant square x and secant square x is equals to tan x plus c. Then differentiation of minus cot x is cosecant square x, and here cosecant square x is equals to minus cot x plus c. Then secant x is equals to secant x tan x, and integration of secant x tan x is secant x plus c. Then differentiation of minus cosecant x is equals to cosecant x cot x, and integration of cosecant x cot x is minus cosecant x plus c. Here we can see this in integration. Wherever you have c in this solution, that is in the answer, all the values of c is negative for integration. It is cos, whether it is a cos, whether it is cot, or whether it is cosecant. The values in integration will be negative for the term which begins with the word c. Then moving with the next question. The next formula is secant inverse of x. Differentiation of secant inverse of x is 1 by root of 1 minus x square. Whereas integration of 1 by root of 1 minus x square is sin inverse of x. Then differentiation of minus cos inverse of x is 1 by root of 1 minus sin square. Same, it is similar, same for sin and cos. Here the different integration of 1 by root of 1 minus x square is minus cos inverse of x. I said you, whenever it is cos or cosecant or cot, the sign is negative for integration. Then differentiation of tan inverse of x is 1 by 1 plus x square. Then integration of 1 by 1 plus x square is tan inverse of x. Then differentiation of e power x is e power x, and integration of e power x is e power x plus c. Then differentiation of log x is 1 by x, integration of log x is integration of 1 by x is log x. Then differentiation of ax divided by log a is ax, and integration of ax is ax divided by log a plus c. So these are the some important formulas which we'll be using to solve the functions and integration part in the coming syllabus. Some of the important properties of integrals. We have some important properties of integral. Here the property of integral, the first property says the Process of differentiation of integrations are inverse of each other in the sense of the following result. I just now said you the differentiation and integration are opposite of each other, or inverse of each other, where we see that cos x is changing to sin x and the integration of sin x is minus cos x. So here it says the same thing, the different property. It says that integration and differentiation are inverse of each other. Then the second property says two indefinite integrals with the same derivatives lead to the same family of the curve, and so they are equivalent. If they are having the same integral derivative, then they are equal to each other. Say is the second property. The third property says integral of f of x plus g of f. If you have two functions, then we can separate them and write as integral of f of x dx plus integral of g of x dx. Then property 4 says for all real numbers, if there is a constant k of f of x, then we can write that constant outside and we can integrate the function k integral of f of x dx. Property 5 is a combination of 3 and 4. By property 3 and 4 can be generated to a finite number of functions f1, f2, fn and real numbers k1, k2 and kn, giving that if you have integral of k1 f1 of x plus k2 f2 of x plus so on kn fn f of x dx, then we can write the constant k1 f1 of x dx plus k2 f2 x dx plus goes on till kn integral of f of n x dx. That is, we can write all the constants and we can add the functions separately. These are the some important functions properties of integral which we'll be using while solving the problem. Thank you for watching. If you like my channel, subscribe and share and comment for the coming videos. Thank you for watching.